In exercise 2E, we're introduced to one of the new methods for solving a trig equation. Remember I spoke about that you would learn 2 more methods for solving trig equations? Well, this is one of them. It's called the auxiliary method. And if you look up some definitions for auxiliary, you might see assisting, supporting, ancillary. I like to think of the auxiliary method as in addition to, just in addition to. So what actually happens is you have a trig equation, and let's say you're required to find x in this equation, and x represents one of the angles. Then you need to introduce a second angle, for example, y. Now, we're going to create a situation that, again, previously I've said, oh, well, actually, we don't get that. We're not asked to solve an equation where the 2 angles are of 2 different names. And that was back here when I was talking about, well, at least that was an x and that was an x. But now, with this method, you're going to actually have in an equation, you're going to create this equation. You're going to add what seems to be another step of complication, in that you're introducing a different named angle. Now, and that is called the auxiliary angle. The places where you will use this method will actually look like equations will be of the form, for example, now A sine x plus B cos x equals C. So what can we see there? A is a constant, got another constant here, and we've got a constant there. Of course, those constants could be the numbers 1. We could have a 0 here. We could have, as you can see here, some examples. We've got a 3, and we've got a 4, and we've got a -2. Now, these aren't necessarily 9s and 7s and 3s. These aren't necessarily numbers we like or are familiar with. The root 3 here and the 1, yes, but not the 7 and a -2 and a 5. You can see that you'll have sine of x and cos of x. Now, the angle is staying the same name in that it's called x and x. So, yes, we've got that x and x and x and x. So they all have an x. And in some ways, we describe these equations that we're required to solve as quite simple. That is a simple sine x. What can we do with sine x? Not much. Cos of x, we can't do anything. It's not like we can replace cos of x with something else about sine x. So in some ways, these equations are almost too simple. And when you recognise you've got that situation, then you need to make the connection to this auxiliary method. It's not possible to do use the auxiliary method without knowing these. And you know that 2 of those appear on the reference sheet. The sine of the plus, that's that one, and cos of the plus. You can probably make the adjustments yourself for the minuses and from the reference sheet. So in some ways you've got these. You don't have to learn them. You have them. What you do have to know to do is make reference to them, because this auxiliary method depends totally on you being familiar with this situation. So much so that it's more like you have this situation and you've got to connect it back to one of these expressions. So it's not so much you will replace these, but you will recognise that this situation is actually equal to that expression, trig expression, with the addition of angles or subtraction of angles. So you can see throughout here, sometimes we have a minus in here, sometimes we have a plus, sometimes a plus and a minus. So we can see through here, sometimes we have a plus, sometimes we have a minus, sometimes we have a plus. So it's very much a pattern matching exercise. Pattern matching. If your pattern here matches one of these, then you can say that you can work with that and you've got something else that is actually equal to. So if we're using nothing else but our ability to match patterns, we can see that I think fits nicely here. We've got a sign A, which they call sin x. We've got a minus. We've got a cos x, which we'll call cos A. We then know that cos of B would be this number, and we know that sine of B would be that number. So and we know that we could overall replace this expression here with sine of A minus B, as long as we've got this understanding. So now back to the actual steps of the method. The auxiliary angle method is used to solve equations in this format, where A, B and C are constants, and you could have a minus in there as well. An angle will be introduced. You will introduce an angle, hence the name auxiliary, in addition to. You'll need to find the value of the auxiliary angle before you can solve for the value of x in the original equation. I think even at this stage it'd be a good idea if you actually wrote that for yourself, step 1, step 2, and already have this method, the process of this method, being organised in your own mind. And because we will be focusing on matching things up, working through the process, we don't want the additional strain on our memory about these. So make sure you are familiar with them. I know that they're written on the formula sheet. Your way of working through these questions might be to always have that formula sheet there next to you. Write in the additional equations you need, the ones with the minus, and keep that beside you every time you do a question. And just one more thing that we need also to be aware of is that actually it will be rare that you've got something this simple and it will have a 1 at the front of the sign here. So you just have to trust me on this. In order for us to be able to deal with that situation, we're simply introducing an r. An r is just another variable. It's not a variable, it's another constant. We will work out the value of r. We will draw some little triangles. We will know what r is. But what it enables us to do is to make these a little bit more, appropriate for the situations we'll get. So any situation where we have a number out the front as well as this expression, I'm sure you can see that all we're doing is introducing an r to both sides of the original equation. So it becomes r at the front of that would be r times that term. And if we put that in a bracket, well, we can take the r out the front. The same with the other 3 expressions. So now you might have as step 3, introduce the concept of r and find the value of r. Some features of these equations will be the equation that you're given to solve will contain single powers of sine and cos, and they'll have the same angle name. So we've got cos of A and sine of A. So we've got the same name. Now that's not unlike the previous equations that you were solving. except for the one that I pointed out at the beginning of this video. And like it says here in point 3, the aim of the auxiliary method is to replace this, which has 2 trig ratios in it, with something simpler like this. So we are going to replace the left-hand side mix of sines and cos into a simpler expression just involving 1 trig ratio. I think you've seen that before as well. And we know the advantage of only having 1 trig ratio. However, while we think we've made it look simpler because we've reduced the types of trig ratios, what we have done is we've introduced a constant r and we've introduced our auxiliary angle, so we need to be able to find the values of those, and that is going to be very simple. You'll see it's just through using Pythagoras' theorem. So I think the method is really important to get a good understanding of here. I'm going to stop this video so that you have the opportunity to really get sorted what the process is before we even do one example.